We want to find all solutions on the interval from 0 to 2 pi with exact answers. I see that this equation involves just cosine, but the argument or angle is different. One's a 2x and one's an x. In order to work with these to solve them and factor them, we're going to want them to be the same. So I'm going to think of the double angle identity for cosine, and there's actually 3 different versions of it, and this will be a case so you can see why to use one version over another. So here's the first version. Also, if I replace the cosine squared x using a Pythagorean identity with 1 minus sine squared x, I get the second version, which is 1 minus 2 sine squared x. And if I instead replace the sine squared x with the Pythagorean, using the Pythagorean theorem, I get 1 minus cosine squared x. And if we distribute that negative through, that's going to give us 2 on the cosine, and then it's going to be minus 1. So what version would we want to use? Well, looking at this problem, I have a cosine term, so I want to try and get everything in terms of cosine, so I'm going to use this version so that I can get everything in terms of cosine, get it all on one side, equals 0, and factor it. If I'd looked at that term on the right hand side and it would have been a sine term, then I would have used this second version and gotten everything in terms of sine. So that let me determine that I want to use the version that just has a cosine in it. So I'm going to replace cosine 2x with 2 cosine squared x minus 1. And then I'm going to subtract 1 and add 3 cosine x to both sides to get this other side to be 0. And I'll have subtract 1 and add 3 cosine x on that side equals 0. So now let's round up like terms and put it in descending order so I can see about factoring it. So this is 2 cosine squared, then we're going to put the cosine term, 3 cosine x, and then minus 2 equals 0. So now I'm ready to factor that, and if it's hard for you to think about factoring with Trig's functions, you could replace the cosine x terms with a u, so it would be 2u squared plus 3u minus 2, and you could factor that and solve for it. Once you know what u equals, then you can resubstitute and put in cosine x. I'm just going to leave it with the cosine in and factor it because I think I can do that. So first times first needs to give me 2 cosine squared x, so that'll work. To get a negative end, I need 1 plus and 1 minus. Now I'm going to need the plus over here, so when I multiply to here, then I'll be able to get a positive in the middle, and the factors are 2 and 1, and I want to put the 2 here and the 1 here, and that one was a minus, so that if I do outers I get 4 cosine x, inners minus cosine x, and that gives me the right middle term. So there's my factors. Now I'm going to set the first factor equal to 0 and solve it. So that's going to be cosine x equal 1/2, adding 1 to both sides and then dividing by 2. And then I'm going to set the second factor equal to 0 and solve it. Subtracting 2 from both sides, I have cosine x equal negative 2. So looking at this first equation, where on the interval between 0 and 2 pi is the cosine 1/2. Cosine's the x value, so right here the x is positive, and that's littler x, bigger y, so that's the 1/2 for the x. And also down here x value is positive, so it's going to be at x equal pi thirds or 5 pi thirds. Now looking at this second one, cosine x equal negative 2 can never happen. The smallest cosine ever gets is negative 1. The highest it ever gets is 1. This has to be something between or equal to negative 1 to 1. So I just need to throw that one out, and these are my solutions.